Hello everyone, this is Cbse and in this video we are going to solve few questions from the Ncert Exemplar book, and these questions are from the chapter electricity. So this video is going to be very useful for your board exam preparation. So let's begin. So look at the first question. The question is a cell, a resistor, a key and an ammeter are arranged as shown in the circuit diagrams of figure 12.1. The current recorded in the ammeter will be dash. You have four options and you have to choose the correct one. The options are maximum in the first diagram, or maximum in the second diagram, or maximum in the third diagram, or the current will be same in all the three cases. So just focus on the three diagrams here. You have one cell, then you have one ammeter, then you have one resistor, and you have a key or a switch. So if you look at all the diagrams, you can see that all these components are joined in series. So we know that in the series combination the current will remain same. Okay, so the only difference is that their orders are different. Okay, if you look at the arrangement, the orders are different, but all of them are joined in series. So in series combination the order does not matter. So in the question, all the three ammeters in all these three diagrams will measure the same current, will record the same current. So option D will be the correct one. So now let us move to the next question. Again you have a question related to circuit diagram. In the following circuits, heat produced in the resistor or combination of resistors connected to a 12-volt battery will be dash. Again you have four options, same in all the cases, or minimum in case 1, maximum in case 2, or maximum in case 3. So how to solve this question? So you can see that in all the diagram we have 12-volt batteries, and if you look at the first diagram we have only one resistor having 2 ohm resistance. In the second diagram again we have a 12-volt battery and that is connected to 2 resistors, each of resistance 2 ohm, and they are joined in series. In the third diagram you have a 12-volt battery. It is connected to the parallel combination of 2 resistors having 2 ohm resistances. So we have to calculate heat produced in all these three circuits, and then we have to compare them. In which circuit the heat produced is maximum, in which circuit the heat produced is minimum. So for that we have to use the formula V square divided by R into T. Okay, so we will keep the circuit on for the same time in all the three cases. So just ignore T here because T will be same in all the three cases. Only focus on, and you can see that the voltage is also same in all the three diagrams. The voltage will be same, that is 12 volt. The only difference is that the resistance. Okay, so in the first circuit R equal to 2 ohm. In the second circuit R equal to 4 ohm because you have 2 resistors, each of 2 ohm resistance. So the R equivalent will be 4 ohm. In the third circuit the equivalent resistance will be 1 ohm because you have 2 resistors, each of 2 ohm, and they are joined in parallel. If you put the formula to calculate the parallel equivalent resistance, you will see that it is 1 ohm. So you can see that in this formula H equal to the heat energy equal to V square T by R. V is constant, 12 volt in all the circuit. Time is also constant. We will keep the circuit on for the same time. So heat energy produced is inversely proportional to resistance of the circuit. It means if the resistance is minimum, then the maximum heat will be produced, and if the resistance is maximum, then minimum heat will be produced. So now compare the three diagrams. You will see that in the third diagram equivalent resistance is the minimum, which is 1 ohm. So in the third circuit you will get maximum heat energy. Okay, so you look at the option D, maximum in case 3. So this is the correct answer. Maximum in case 2, this is wrong answer. Minimum in case 1, this is also wrong answer because minimum will be in case 2, because I had told you that if resistance is maximum then heat energy is minimum. So if you compare the three circuit diagrams, then the resistance is maximum in the second diagram. Okay, so in the second case you'll get minimum heat energy. Okay, and it is also, the first option is also wrong, so option D is the correct one. So in this way you can solve this question. And now let us move to the next one. It is a very easy question. Electrical resistivity of a given metallic wire depends upon what? Its length, its thickness, its shape, or nature of the material. So remember that resistivity does not depend upon the geometry of the material, like the length, the area cross section, or the shape of the conductor. It only depends upon the nature of the material and also on the temperature. Okay, so out of the four options you have to choose the correct one, which is the option D. So resistivity depends upon the nature of material. Now let's go to the next question. A current of 1 ampere is drawn by a filament of an electric bulb. Okay, number of electrons passing through a cross section of the filament in 16 seconds would be roughly dash. So here current is given, which is 1 ampere. So the filament is drawing 1 ampere of current, and you have to calculate that how many number of electrons are passing through a cross section of the filament in 16 seconds. So time is also given, which is 16 seconds. So if the filament is drawing 1 ampere of current for 16 seconds, then let us calculate what is the total charge flowing through the filament. So Q equal to I into T. So I is 1 ampere, T is 16 second. So ampere into second will be coulomb. So 1 into 16 will be 16. So answer is 16 coulomb. Okay, so the total charge is 16 coulomb, but we have to calculate how many electrons are passing through it. So we know that the charge of one electron is E equal to 1.6 into 10 to the power minus 19 coulomb. This is the magnitude of charge of electron. So one electron has this much charge. So in this question we calculate that 16 coulomb of charge is flowing through the filament in 16 seconds. So how many electrons will constitute 16 coulomb of charge? Simply divide them. So 16 coulomb divided by 1.6 into 10 to the power minus 19. Okay, so if you look at these answers, then you can say that 16 by 1.6 will be 10, and this 10 to the power minus 19 will go to the numerator. It becomes 10 to the power plus 19. So 10 into 10 to the power plus 19 will be 10 to the power 20. Okay, so option A will be the correct option. Okay, so now we'll move to the next question. So this question is again based on the diagram. Identify the circuit in which the electrical components have been properly connected. So you have four diagrams, and you have to tell me that in which diagram all the components are properly arranged. So let us check one by one. The first diagram, it is wrong because voltmeter is connected in series here. Do you know that voltmeter is always connected in parallel? So this is wrong. Now look at the second diagram here. In this diagram you can see that voltmeter is connected in parallel across the resistor. That is correct. Ammeter is also joined in series. Okay, but there is one mistake here. Look at the polarity of the battery. This is the battery. So this, the left side is positive, right side is negative. But look at the ammeter here. Okay, in this case, no, I think this one is correct. Okay, okay, this end is positive, this end is negative, so this is correct. Let us take the other two. This is wrong because ammeter is joined in parallel. That is not possible. So this is not right because always the ammeter is joined in series. Now look at this one. Okay, this is also wrong because here you have negative of the battery, the negative polarity, but on this side in the ammeter it is a positive sign. So this is wrong. So option 2 will be the correct one. So if you look at the options, then yes, option B. So the second diagram is the correct one. All other three are wrong. So now let's go to the next question. Okay, very easy one. What is the maximum resistance which can be made using 5 resistors each of 1 by 5 ohm. So you have total 5 resistors and all the resistors are identical, they have resistance 1.5 ohm. So you have the job to obtain maximum resistance. So remember that to obtain maximum resistance you have to connect all the resistors in series. So if you have 1 by 5 ohm resistors and the total 5 numbers of resistors are there, so the maximum resistance that you can obtain from it is the series combination. So in series combination what happens, all the resistances will be added up. So you have 5 resistors each of 1 by 5 ohm. The answer will be 5 into 1 by 5 ohm, that is equal to 1 ohm. So you can obtain maximum 1 ohm of resistance. So option D is the correct one. Question number 7. What is the minimum resistance which can be made using 5 resistors each of 1 by 5 ohm? Again, remember that if you have a number of resistors and you want to obtain the minimum resistance, then simply join them in parallel. Okay, if you join all the resistors in parallel, then you will get the minimum resistance. So in this question you have 5 resistors each of resistance 1 by 5 ohm, and the question is what is the minimum resistance that you can obtain. Again, you have to join them in parallel, and if you have identical resistors, suppose you have a number of identical resistors each having resistance R, then what is the equivalent resistance in parallel combination? Rp will be equal to R by N. Rp is equal to R by N. So R is 1 by 5 and N is also 5. So the answer will be 1 by 25. So the minimum resistance that you can get is 1 by 25 ohm, and the maximum resistance you can get is 1 ohm, that is the series combination. Okay. Look at the next question. The question is a cylindrical conductor of length L and uniform area of cross section A has a resistance R. Another conductor of length 2L and resistance R of the same material has area of cross section dash. Okay, so it is given that you have 2 conductors, but both of them are made from the same material. It means they have the same resistivity. But conductor A and conductor B, they have different dimensions, means they have different sizes. So the conductor A, the first conductor, has length L and the area of cross section is A. Okay, and rho is the resistivity. So the resistance R will be equal to rho L by A. Okay, R equal to rho L by A. Now look at the question. Another conductor of length 2L, this B, the conductor B has length 2L and it also has the same resistance R. It means resistance of A and that of B are equal. Okay, so RA, this is RA and this is RB. RA and RB are equal. So how to write the value of RB? Resistivity into length of B divided by area of B. Okay, so rho into length of B is 12 divided by area of B. So this is the expression for RA, this is for RB, and according to question both have the same value. So you can write that RA is equal to RB, that implies rho L by A is equal to rho 2L by area of B. So here rho L will get cancelled. AB will be equal to twice of A. So the option will be option C. It means the area cross section of the second conductor will be twice that of the first conductor. Okay, so in this way you can solve this question. Okay, next question. In an electrical circuit, 3 incandescent bulbs A, B and C of rating 40 watt, 60 watt and 100 watt respectively are connected in parallel, okay, to an electric source. Which of the following is likely to happen regarding their brightness? So you have 3 electric bulbs, one is 40 watt, the second one is 60 watt, the third one is 100 watt. So remember one point, that if electric bulbs of different wattage or different powers are joined in parallel, then the bulb having maximum power or higher power will have higher brightness. So more power means more brightness if they are joined in parallel. So in this question it is also given that they are connected in parallel. So definitely we will see that which one has the maximum power, that is 100 watt. So 100 watt will have the maximum brightness and 40 watt will have the minimum brightness. So now read all the options. The first option is that brightness of all the bulbs will be same. This is wrong. Second option, brightness of bulb A will be maximum. Again it is wrong, because bulb A has minimum power, so it will have minimum brightness. Option C, brightness of bulb B will be more than bulb A. Yes, this is correct, because bulb B has more power, 60 watt, and bulb A has less power, which is 40 watt. So bulb B will have more brightness. Brightness of bulb C will be less than that of B. This is wrong, because C has maximum power, so it will have maximum brightness. Okay, so C will have a brightness more than B, not less than B. So option C is the correct option. Next question. In an electrical circuit, two resistors of 2 ohm and 4 ohm respectively are connected to a series of 6 volt battery. The heat dissipated by the 4 ohm resistor in 5 seconds will be dash. So you have 2 resistors, one is of 2 ohm, the second is of 4 ohm, and they are connected in series to a 6 volt battery. So this battery has voltage 6 volt. You have a 2 ohm resistor and then a 4 ohm resistor. So what you have to calculate? You have to calculate the heat dissipated by the 4 ohm resistor in 5 seconds. Okay, so to calculate heat energy, you have to use the formula I square R into T, or you can also use V square T by R, but for that you have to calculate the voltage across the 4 ohm resistor, because we are finding the heat produced by the 4 ohm resistor, not through the combination. So let us calculate what is the current flowing in the circuit. So the total resistance will be 6 ohm, 2 ohm plus 4 ohm. So R equivalent is equal to 6 ohm, and the total voltage is 6 volt. So current will be 6 volt by 6 ohm, that equal to 1 ampere. So in this circuit 1 ampere current will flow, and when this current will flow through the 4 ohm resistor for a time of 5 seconds, how much heat energy will be produced? Look at the formula I square RT. So I is 1 ampere, so write 1 square into R. R is 4 ohm into T. T is 5 seconds, so it will be 20 joule. So option C is the correct one. Next question. An electric kettle consumes 1 kilowatt of electric power. So power is given 1 kilowatt, or it is 1000 watt. When operated at 220 volts, so that electric kettle is being used at 220 volt. So voltage is given, the operating voltage, which is 220 volt. The question is, a fuse wire of what rating must be used for it? So you have to use the fuse wire because of safety reason. So the question is, the fuse wire should have rating dash. So remember that if you know the power of an appliance and the operating voltage, then you can calculate the maximum current that can pass through it, the safe limit of current, using the formula I equal to P by V. We know that P equal to VI, so I will be P by V. So P is 1000 watt divided by V is 220 volt. So if you divide it, you will get around 4.5 something. Okay, so remember that this is the safe limit of current, 4.5 ampere. So the rating of the fuse will be slightly above this safe limit of current. It cannot be less than that. It will be slightly above the safe limit of current. So look at the four options. You have 1 ampere, 2 ampere, 4 ampere, 5 ampere. So you cannot use any of the first three fuses. The only value is 5 ampere, which is slightly above 4.5 ampere. So option D will be the correct one. So you have to use a fuse of rating 5 ampere. Okay. So now let us go to the next question. The question is two resistors of resistance 2 ohm and 4 ohm connected to a battery will have dash. So you have two resistors 2 ohm and 4 ohm, and you have to connect them to a battery. So now let us read the four options. Same current flowing through them when connected in parallel. This is wrong, because we know that in parallel combination voltage remains same, the current will be different. Second option, same current flowing through them when connected in series. Yes, this is correct, because we know that in series combination of resistors same current flows through all of them. So if you connect the 2 ohm resistor and the 4 ohm resistor in series across a battery, then the same current will flow through them when they are in series. Option C, same potential difference across them when connected in series. No, this is wrong, because in series combination current remains same, the potential difference but the voltage gets divided. Okay. Last option, different potential difference across them when connected in parallel. Again, this is wrong, because when the appliances or the resistors are joined in parallel, they have the same voltage or the same potential difference. So option D is also wrong, only option B is the correct one. So last question of this video, easy one. Unit of electric power may also be expressed as dash. So we know that power has many formulas like V into I, V square by R, or I square into R. So based on these formulas, let us find the unit. So volt into ampere. So volt means voltage, ampere means current. So if you multiplying voltage with current, you are getting power. So option A is the correct one. Let's go to the other options. Kilowatt hour. So kilowatt is the unit of power and hour is the unit of time. So if you multiply power with time, you will get energy. The second option is for the unit for energy. Then you have watt second. Again, watt is power, second is time. So again you are getting some energy. So watt into second will be joule. Then you have joule into second, means energy into time. So this cannot be power. So only there is one option correct, which is option A. So students, in this video we have discussed a few MCQs from this chapter, and in the coming videos we'll also discuss about some more questions. But I am sure that, and I hope that all of you have understood the solutions to all the questions. Okay, these questions are not very difficult, they are very easy question. Just you have to use your brain, use the concept, and very easily you can find the answer. Okay, so we'll meet in the next video with some new questions. So till then, have a nice day and bye bye.